I'll just elaborate on the introduction a little bit and welcome everyone. Thanks for joining. I work at Quantsite Labs, and my co-presenter today is Jaime. Jaime couldn't be here today, unfortunately, but that's all right. I do want to shout him out because he played a very critical role in putting this talk together, especially the primary framework we look at today was all Jaime. So both of us work at Quantsite. Jaime works on a lot of conda tooling. I work on conda store, which we'll also discuss towards the end of the talk. But I work on Nibari and Bokeh, two other tools in the PyData ecosystem. Okay, so let's, I guess, get some context, what this talk is about, and then we'll slowly dive in. So the title suggests runtime reproducibility. So let's start with what this even means, right? And what are we talking about today? So almost all the time we discuss runtime reproducibility, it narrows down to these 5 words. It works on my machine. And it can be your application, your script, your notebook. However, for today, because this is runtime reproducibility, we are not concerned with the library and building packages as much as the final end user experience, right? And what does works mean? An imperfect definition is repeated installation and execution steps provide a consistently correct result. A lot of words, but we have the rest of the talk to understand that. And finally, your machine can be, oh, my video is covering it, but I'll just read it out. Vague definition of hardware, OS, kernel, libraries, executable binaries, a lot of things form the machine part here. Sometimes it's also not just your system. It can be slightly, it's the space around it, that the current date can sometimes affect your runtime environment because it can serve as a seed for something else, right? So that is what we are covering. And honestly, packaging itself, Python packaging in general, is a very deep, broad, vast rabbit hole. And we are not going to enter that rabbit hole. We are just going to run around the rabbit warren, and there's a lot we can do there, honestly. And that's what we're going to cover today. Right. So in open science, this is a wonderful matrix created by the Turing Way community. They define reproducibility as, actually, I have Turing Way right here. They define reproducibility as when the same analysis steps performed on the same data set consistently produce the same answer. So we have data and analysis. There is a layer missing here, right? Or you can also consider that a part of analysis, which is tooling. And the tooling part is also critical in reproducibility, and that's the part we are going to focus on. Now, I guess, I think the context is clear, what we're talking about in terms of runtime reproducibility. Now, the key takeaway in this talk, honestly, is this. To ensure runtime reproducibility, we need to be proactive about it. And how to do that is what we're going to cover. Reproducibility cannot be an afterthought and needs to be modeled early. That's what we mean by being proactive, right? And how do we do that? We can borrow a framework from threat modeling. And why do we do that? Because threat modeling also needs to be super proactive, right? Security, you can't think of security, when there's a security breach, it's too late. So we need to be planning for that very early on. So the 4 steps in this framework are defining your objectives for reproducibility, enumerating components, evaluating threats, and finally, once you know the threats, you apply reasonable measures to overcome them. Going through these one by one. So what do we mean by defining objectives? Here, the whole idea is to think about this before the application is complete. So you're thinking about when you're working on something, what is my definition of reproducibility for this application? Let's just take application as an example for today, right? So it can be, when you say, for example, I wanted to work on my machine, but what exactly do you mean by that? Is it just your machine? Is it your machine in 2 years? Is it all the machines in your organization? Should this work in a deployed setting? Does this need to work on everybody's computer across the planet? So defining what reproducibility means for your particular use case is step 1. Next is enumerate components. So once you have that definition, you can now start looking at your software, your work, and find pieces that you need to look at, right? And you can categorize them as things that you own, right? These are things you have control over, which usually includes your software itself, but also some data or your server. There are some things you will need to delegate out, like all the dependencies. Like I think you cannot realistically manage all the dependencies that your application needs, right? And at that level, you need to delegate that out to other maintainers in the ecosystem. Sometimes it's also your infrastructure that we delegate out. So next is looking at the pieces of your work. Sorry, three, yes. Three is evaluating the thread. Now that we know the pieces, we can think about what happens if this piece doesn't behave the way I expect it to. So an example here is we looked at server and data, right? What happens if where I've stored my data, that goes down? Is that a risk I'm willing to accept, right? Like, what is the risk here even? So, or your server goes down, or like there are some dependencies, right? So maybe looking at I have like these 15 dependencies. Maybe 3 of these are super critical. What is the threat level or the risk level if these 3 somehow break? So looking at and evaluating all the threat aspects here. And once you know the threats, you can apply certain measures. So when we identified those 3 critical packages, maybe you decide to render them to minimize the risk. If you think your data is not stored as, if one place is not enough, build in redundancy there. So you can then apply certain measures. So with these 4, this is like the framework that we follow. Now let's look at a concrete example of Python in web. That's also really cool. So that's kind of why we chose this example. But this same framework applies across the board for notebooks and scripts and such. So this is just a basic example. I'll walk you through what we did, right? We were looking at Wakes and Streamlit. Like there was a blog post that we found, which was super interesting, building a web app. And actually, taking a step back, what is Streamlit and Wakes for folks who are not familiar? I don't want to just throw jargon out there. So Streamlit is a library that lets you build web applications in Python, right? It's really cool, like lets you build a lot of things pretty quickly. And Wakes is a high performance data frame library. So you can do things a little faster than, I think, very different libraries, okay? So these are the apps. You're putting them together to create like, a cool web app. Now, the first thing we noticed was the blog post was very nice, but the hosted app was down because the website was down because of some DNS errors. Of course, it's DNS errors. However, the source was available in the blog post, so that's awesome. We went to GitHub, and there were requirements.txt files. So now I know that I can rebuild this on my machine and then check it out. The requirements.txt file ran pretty smoothly. Like there was one typo, but other than that, we just assumed a Python version. Python version was not specified, so that's an assumption we made. And then things kind of worked. Like that's why there's a JIT there. However, what this doesn't encompass is was a really large dependency tree behind the scenes, right? So at best, the requirements.txt was underspecified. Now, what does this mean? Like, this is not like a particular, like taking a dig at somebody. That's not the case here. Like I have done this before, right? There are applications I wrote 3 months ago that don't run right now because I didn't do certain things for reproducibility. So let's look at what actually happened here. The main thing is a lot of things were delegated out. What were these things? The app runs on Streamlit Cloud, but the domain was down. The hosting bit was being delegated. It wasn't in the owned section. Second, dependencies rely on PyPI and Angular being online, which is a level of risk I think most folks are okay with accepting, right? The Python version wasn't specified, so that is delegating the Python version aspect to the users. Like, but maybe maybe I end up using like, I don't know, Python 3.6. Will it still run? I don't know. But we obviously chose a recent one, like a more recent version. Sorry. And lastly, platform OS is obviously needs to be inferred again, being delegated to the user, which is me. I ran this on my like Mac machine, and I just hope that it worked, but maybe it doesn't because this was only tested on a Linux machine. But that information wasn't presented anywhere. So that's where this is like a concrete example of where reproducibility measures weren't taken to the. Maybe this is okay. The point is not to you don't have to do these things. The only thing I want to like get across here is like being aware of where you're drawing the line. Okay. Next is how do we improve this now? We can take 6 levels of trust, but it's also 6 levels of paranoia, right? So first things first, we can have explicit source of packages and Python interpreters. So a lot of like at least at one side, a lot of folks love conda, so we end up using conda in environment.yaml. In this example that we just saw, a requirements.txt was specified. Maybe they were expecting folks to use pip and PyPI, but being a little more explicit about that is always good. You can also include the operating systems that this application supports, so if you want to build it locally. Right? So being explicit is just step one. You're really putting in a lot of trust in your delegated box. Next step is you can provide a log file. So this will include all the dependencies that we saw in the previous slides, right? So this log file will have all the dependencies and the exact versions of your packages and the versions of the dependent packages. You can use in the conda world. We have conda log. It's an excellent tool, but you can also do a pip freeze if you prefer. After that, maybe that's not enough, right? You trust your the delegated box even less, like, or you're even more paranoid. You can include a tarball with all the conda packages. That's not enough. You can include a Docker image. If that's not enough, you can provide a VM with conda. That's also not enough. You can just ship an entire PC with everything you want. Of course, that's like a very, very extreme case, right? So this is just showing you the levels of reproducibility. Like at 6, you're actually fully ensuring reproducibility. But as I said again, like we don't have to do all of these. Just making a conscious decision about where you draw the line. That's what we want to get across. A small note here is when you ship and vendor packages, licensing is important to look at. Like you may not need to include certain licensing files. Like maybe you don't have the correct, maybe the license doesn't allow you to do that. So that's something to consider when you look at the last few options. Now, now that we've looked at runtime reproducibility, generally, data science and PyData ecosystem in general, we have an extra set of needs beyond what we just saw. We have multiple languages and several packaging ecosystems, like very few packages, rather, even the base foundational packages like NumPy, SciPy, they are not pure Python packages, right? So we need to, that adds some complexity in this system. Next is, especially with the recent AI hype, I guess, but also like just there's a lot of folks doing data science, and libraries are moving very, very fast, which means it's not always backwards compatible, right? And that is problematic because my application may not work 3 months from now because the library has moved ahead. Things are not compatible anymore. Next is practitioners do the same with their environments. This means like breaking all the things. By this is the same as I think the last point, which is workflows that don't make reproducibility easier. This is kind of the same in a way because our current workflows, especially with conda, I'm a primarily conda user, our workflows don't enable reproducibility. Like it's a lot easier to do conda install NumPy in my new environment. That's not the best practice though, right? Because I'm not adding it to my environment.yaml spec. I'm not building a log file at the end, maybe. So when we have these workflows, and as a practitioner, like I will end up breaking my environment, or at least rather best case, it won't be reproducible if things don't break. So we have extra problems. How do we solve them? Honestly, being aware of them is useful, like as you just did in this talk, like you've learned from this slide, but like, and then you can now build for that. At QuantSite, where I work, we ended up creating a tool to sort of bridge this gap for us. So I'll just show you how we thought of this and did this, but maybe this is too much for you. Maybe this is not enough for you. So that's a decision that you will make for yourself. So just to give an overview of what we are trying to do, we want things to stay reproducible. We want data science environments, which we saw comes with additional complexities to stay reproducible, but also be flexible and easy to use, because if the workflow for reproducibility is harder, folks will inevitably just fall back to older patterns, which may not ensure reproducibility, right? Okay. So a few things that we did in conda to help with this is we built in a UI. I actually have a local demo running. So this is conda. I'm running this locally. If you want to do it, I'll share the code at the end. So this is just a UI view, but also a standard YAML editor if folks prefer that. And we can hit create. So this kind of lowered this added a little more, made the workflow section of following things easier, having a UI, an intuitive-ish UI, right? Like we know exactly what to do. Like I add packages here because there is a button that says add packages here. I don't have to go through the CLI and think about like 3 commands. Next is, we have version control. This is an environment I just built for PyData globals. I'm just going to go back to an environment I built earlier. And here I have this one I built today, but there's also a version of this from November. So if I end up breaking this environment, inevitably, like if my build today broke the environment, I can just fall back on the previous version I built, and that was successfully built. Next is enforcing practices for groups. So this is not super obvious from my local setup, but in a hosted version, we can require certain, oh my God, I'm so sorry. Yeah, we can require the use of like internal mirrors. We can restrict certain channels. So we can say only use conda or only use this particular channel. This is underlying conda is built on the conda ecosystem. So that's where the channels vocabulary comes from. Third is insert required packages into all environments. So I've highlighted IPy here. We need that for certain other things in the system. So we just make sure every environment built will just have IPy installed by default. And lastly, require certain versions of packages. Maybe you haven't tested the latest version of pandas. So you want to make sure every environment built in your team just uses a version below that, right? Like or a certain version. You can do all of that. So enforcing best practices from a user's perspective, I still have my interface, and I can say, give me pandas, and like I have my drop down, and it will only give me certain versions, and I just pick one of them, making the workflow easier, but also enforcing certain things. And this I will show you in conda. By default, a bunch of artifacts are created. This includes a YAML, but this is a pinned YAML. This includes all the dependencies and exact versions, but also a log file, which is the exact hash of this, but also the log file also includes the platform details, so extra hardware information, and a log file and an archive. In the hosted version, we also have a Docker. It should be there somewhere. Yeah, we also create a Docker image and a tarball. So these are, again, created behind the scenes. I don't have to worry about it. These are required for reproducibility, but I don't have to create these manually. So with that, to try conda for yourself, this is, I'm hosting this locally, and the local setup for conda is only for early adopters. This isn't in the released version yet. But to do so, you can look at the slide, maybe take a screenshot or pause if this is a video and follow along. Okay, so that was that. But that's where these are the few things that conda did, and like, that was enough for our team. But maybe you need to go further, right? You want to specify the hardware kernel versions. Maybe you want to, have a full VM, and yeah, you can add more and like design a system for yourself that works. And finally, just a note again is the workflows should enable reproducibility. Like you can have the most reproducible system, but unless folks follow it, it's not really useful. And finally, with that, we've come to the end of the talk. So I'll leave you with some key takeaways. First things first, we discussed like looking at and making reproducibility, being proactive about it. So analyzing supply chains, enumerating components, thinking about risk. Capturing runtime details that you don't control, which is a part of the framework, right? And here, we're just shouting out a tool called Watermark. So this is an IPython magic. that lets you, sorry, that prints a few hardware information, like some hardware information, like in your Jupyter notebook, and you can just include this, right, when you do version control or share your notebook with other folks. So other runtime details you want to capture are any randomness, date and time. Of course, version control is useful, as we saw with conda store. And after that, there is an accepted level of risk. You're going to have to make a decision about risk. Just make sure it's an educated compromise that you make. And finally, test your work. I don't think we covered this specifically, but it's definitely important. If your reproducibility workflow is bad, it's kind of worse than not having reproducibility in some sense. So yeah, with that, we can open for questions. Thank you so much for time. Do we have the moderator here for the Q&A? Or I'll open the chat just a second. If you have any questions, you can drop them in the chat. Is this tied to the conda ecosystem, or does it work without conda? Conda store is built on top of the conda ecosystem. It's actually a part of the conda incubator organization. So it uses conda internally, right? But conda itself is kind of, it's not button specific, right? You can install Node.js from conda. So conda does have some flexibility, but conda store is currently built on top of conda. Any other questions? Does it work with Mamba? It obviously can. Like Mamba is also part of the broader conda ecosystem. So once you have the environment.yaml that's like created for you, like the pinned YAML or the log file, you can do a Mamba install. So you can definitely use Mamba locally if you want, but like underneath, like by default, conda store, like how the first initial packages, like a first environment is built for you, is using conda solver. Any other questions? So we do have time. So if there's also something you want to go back on, I can show off conda store some more if needed. Actually, I didn't get around to doing this, but this blog post by Anaconda talks about 8 levels of reproducibility. It's a really nice blog post to check out if you're interested in reproducibility. We did refer to this while preparing the talk as well. Okay, looks like we don't have any more questions. So thank you all for joining. I guess I'll try to close this session.